Hi, welcome. In Lab 3, we are going to focus on data balancing strategies to improve land cover classification. Remember, in Lab 1, we observed that our training dataset was highly imbalanced. This means that some land cover classes were more dominant than the others. For example, we observed that built-up areas and grass open areas had more training data points than the other land cover classes. In this tutorial, we are going to explore how upsampling or oversampling can help us minimize the impact of data imbalance. Oversampling simply creates duplicates from the minority land cover classes. This tutorial consists of 4 steps. So these are the same steps that we followed in Lab 2. So in this tutorial, we are not going to go much into details about explaining each step. We are simply going to focus on some key important sections and areas. Okay, so step 1 is just focusing on setting up the work environment. And this is what we did in Lab 1 and Lab 2. And then in step 2, we are just simply going to prepare training and test datasets. We can here note the distribution of the training data points. We can see that the built-up areas and the grass open areas has more training points than the other land cover classes. Okay, so step 3 is the most important because it is here that we are going to define our upsampling or oversampling function. So here we are going to use our upsample function from the current package. What we are simply going to do is we are going to define sampling as up under the train control function. So up simply refers to upsampling or oversampling. Okay, if we run this chunk of code, it's going to take a bit of time. On my machine, it took about 22 minutes to run the model. Okay, so after running the model, we can check the model performance. Important here is the out of the bag estimate of error rate, which is 3.96%. So remember, in the previous labs, we noticed that the out of the bag estimate of error rate was 22%. So this is a significant improvement. This is quite good. So we can also notice that the other land cover classes also have training points that add up to 446. Okay, right. If we check the variable importance, we notice that the built-up areas and water have bands with much less contribution as compared to the other land cover classes. We also notice that there's much more contribution in the woodlands classes. Right. Next, let's check the performance of the model using the new test dataset. So we observe that the overall accuracy is 78%, which is the same as the previous models in Lab 1 and 2. So please take note that the test dataset was not upsampled or oversampled. So that's why we are getting the same result. Right, next we want to check the quality of the lane cover map. Here we can see that we have still the same problems that we observed in the previous labs. Okay, so in the northeastern part of the study area, we have many of these built up pixels which are not really built up. So these are misclassified uh, areas. Okay, so these are very terrible misclassifications. We can also see the same in the southwestern part of the test site. We have a lot of misclassifications. Okay, so that shows that the model is actually not doing a good. Is not doing a good job. Right. So we can use the explainable machine learning methods uh, in order to understand the model behavior. So again, here we are using the dialects package as we have done. So we are simply going to create a new explainer. Okay, and then in this explainer, we can now derive the other interpretations. Okay, for example, here we can look at the feature importance. We notice here that there is an increase in the magnitude of the contributions, but we still have the same pattern of contribution. For example, band 2 contributes the most, while band 7 contributes the least to the random forest model. So if we run the accumulated dependence profile, we can see also the same pattern. We don't observe much significant change in the top 4 importance bands. Okay, so the same goes for the bottom 4 variable importance bands. We don't see much significant change as in the previous lab. So if we go to the Shapley values, again we see the same pattern as in lab 2. Here again we see that the built up areas dominate the overall prediction. Okay, so the same pattern can also be observed when we run the breakdown profile. We can also see that again the built up areas dominate the lane cover classification. So in summary, we can see that upsampling did not improve the lane cover classification. So this is quite important. So this means that we need to look for uh, alternative ways to improve our lane cover classification. Right. Thank you very much for watching this tutorial. Okay. Please download the error code in the link below and then try it yourself. You can also compare with the previous labs. See you in the next tutorial.